Thank you. Thank you, John. That was a very generous introduction. And indeed, it's a great pleasure to be here and wonderful to be giving a talk at OPR and to just reconnect with everyone. And there's an open invitation to come to Seattle. We're trying to generate the kind of warmth and scholarly warmth that happens here at OPR that I remember so fondly. We're also trying to replicate it at CSDE, and so we welcome you there as well. Now, the timing of my talk relative to what happened a few weeks ago was pure coincidence. Some of us may think that there's selectivity here, but really, I had no idea, and so I know that many of you are still reeling after that event. And in fact, my talk is about this particular talk is not going to be about disasters and large events, but what I would argue is probably the more important phenomenon, which is the slower term, long-term, cumulative increase in uncertainty and risk that people are facing. And we have to start, and we can talk at the end. Beth Fussell and I are working on a project that's going to be linking disaster data, natural disaster data with the PSID, so that we can look at long-term trends in exposure to disasters and responses, livelihood adaptation to those. So this project isn't going to be looking at any big disasters. It's looking at variability and changes in typical patterns of climate. And it's a collaborative effort with our local GIS expert at Demography Center, Matt Dunbar, and two graduate students, one in physical anthropology, Benjamin Chabot-Hannawell, and Jacqueline Meyer-Irons, who's a public policy PhD candidate. Just a few acknowledgments. We draw on some funding from a number of different sources. And what I'm going to do today is just briefly review the literature on climate change, variability, and migration, the literature to date, some of the scientific challenges in tackling this topic, the study site that I use in this particular case, which some of you are aware of because of other presentations I've given, and my other research, and then our modeling approach and our results and some next steps. This is quite preliminary in the sense of our initial preliminary estimations of some models. I want to be really specific here about, I'm deliberate about this issue of variability. So conceptually, one of the things that we know might be happening is that there's actually growing variation in patterns of climate outcomes. And that variability, particularly in natural resource-dependent, livelihood-dependent contexts, can increase the risks associated with livelihoods and require some adaptation. So climate change per se, is a moniker that many people use, but it's a combination of this increasing variability, increasing intensity of some particular events, and then an accumulation of changes to localized weather and weather outcomes and patterns of climate locally. So as many of you know, in 2007, the IPCC finally actually came out with some statements about the human dimensions, some specific statements about the human dimensions of climate change. Not so much as drivers of climate change, but what will happen with climate change, what are the consequences of climate change for human systems. And you'll see in the next, well, it's already started in the last year and a half or so, this idea of policymakers are talking about adaptation a lot more than talking about drivers of climate change. In the IPCC report, Asia was pointed out as a place that's going to be particularly vulnerable. And the kinds of communities that will be particularly vulnerable throughout the world, but in Asia as well, are those that are rural and natural resource dependent, especially drought or flood prone, and coastal settlements. So the idea here is that climate change yields new and greater variability in patterns and intensities of particular kinds of events, which leads to increasing food insecurity, lowered health, degradation of land and freshwater resources, and diminished livelihood. And migration can be an adaptive response. And these migrants are sometimes called climate migrants or environmental refugees. And I just list a few of the people that are involved in contributing to this cascading set of hypotheses. More recent, as a result of the IPCC and this early work, there was early work in the mid-2000s. There was subsequently some complicating of the expectations. And maybe one might suggest that there were sort of mixed results on whether what we were really seeing. Importantly, early ideas about migration were relatively simplistic, and they weren't taking into account migration systems and feedbacks, and also early estimations of environmental conditions and what might be a cause of migration were also relatively simplistic. And these early works started to, these subsequent works started to, this literature started to question it. In particular, as I'll note here, a few recent studies that suggest looking at multidimensionality, temporal depth, temporal dynamics, and multiple levels of analysis. And also to be sure to take into account that, in fact, in many places where you're going to probably see migration, there's already, possibly as a result of environmental change, there's already migration systems in place that are fueling migration. So how do we think about seeing whether there's an additive or interactive effect at all with regards to the environmental impact? In addition, I would argue some of the challenges include unpacking the measurement of climate change and concepts. It's both a global and a local phenomenon. So there's variability across spatial scales. Temperature, weather fluctuations, droughts and flooding, differential exposures, timing of exposures, all of these are being increasing, and the slow onset changes are somewhat harder to observe and linked to social data as well. So as you can see, there's a real challenge, and I think we demographers are in a really good place to contribute to meeting this challenge of linking social and environmental data to really tease out causation and get at both better measures and estimation and models of migration in coinciding with better measures of environmental change. Generally, one of the problems in the environmental literature is that there's sort of inconsistent use of what we mean by environmental change. So sometimes there are measures of perception, sometimes that is the perception of people who did or did not migrate. Sometimes we use relatively simplistic measures, mean one-year lag, measures of particular drought or temperature or rainfall or something like that. And then scalar units are generally inconsistently linked to social units. To what extent is someone thinking about their natural environment that they're dependent on? Are they thinking about it in relation to their particular field, or are they thinking about it in relation to their whole villages, the fields surrounding their village, or how do they think about what this means, these climate change means for them? I know I keep talking about evidence. I really think that anybody who's in this field should be reading the things that I'm citing up here, which happen to include one of your colleagues, Doug Massey. But these getting a handle on this literature to scope the scope what has been understood and put it into the context of a wider, more comprehensive scoping of how we understand social processes and environmental processes and their interrelationship. We're getting there, but we're not quite there yet. So we really need to be pushing ourselves to be more complete and comprehensive theoretically and empirically to get at these complexities. Okay, so what do? We don't do everything, but we try to push the world, the literature a little bit, knowledge base a little bit further. We take advantage of a long-term study that's been going on in Thailand that's multi-level and includes village, household, and individual data, and we link to it simultaneously long-term environmental conditions, changes in environmental conditions. We add to our estimations of migration behavior by looking at variable exposures to conditions of global change, environmental change, which I'll explain in a second. And we also look at variability in conditions, environmental conditions, as opposed to mean stress event, exposure to a mean stress event. And we also were exploring the possibility of two kinds of data that might be used in other places where we have rich social science data that we could attach to, relatively easily attach to the social data. So the study focuses on Thailand, and in particular, Thailand is the particular location of the study is known for, in Thailand, climate change scientists have noticed an increasing amount of growing erratic temperature patterns and drought conditions with increasing severity and length. So empirically, the environmental conditions appear to be responding to this climate change. So I'm just getting to my notes. And in particular, Thailand is one of the breadbaskets of Asia. It's an rice exporting country, huge fruit and freshwater prawn production, as well as saltwater prawn production, which are all going to be vulnerable to the consequences of climate change. And in the particular site where I'll be showing you results from, there is a very limited infrastructure for irrigation, so for accommodating any incidences of drought at all. Now, the thing about Thailand is that there's a tremendous amount of rural outmigration, quite common. There's an existing system, migration system at work, both pull and push reasons. And and we've been very lucky to take advantage of data that are available because of a very rich research infrastructure that generates high quality information. So the site is located in a relatively small district in northeastern Thailand. It's about 100 kilometers from the Cambodian border. And it's along an east-west highway that runs from Bangkok out to the Laotian border. That was built by Americans during the Vietnam War. The natural resource conditions in this part of Thailand are notorious for having very thin soils, no irrigation, rain-fed agriculture, which is one of the main, and a monsoonal structured season. That is, there's very little rain from October through March, April, and then you have start to have rain in April, May, June, and it scales back in July and August, and then you start to have a buildup in late August, September, early October. So it's and during these periods of rain, generally people are coming back to their origin communities to help with rice production. And when there's less rain and rice has been harvested, people make temporary trips in to earn money in Bangkok. So this system of temporary migration has been ongoing for some time. The data collection has been taking place since 1984 and involves 41 villages, originally about 7,000 plus households, which now in 2000, now includes 7,000 households and 35,000 people. We have migration histories for those that are most mobile, most likely to be most mobile, for people 13 to 41 between 1984 and 2000. We have sort of there have been people in the field doing qualitative observations, and we've been doing these large-scale surveys. The surveys are all done as complete censuses in all 41 of the original 41 villages. And we've also done follow-up migration surveys in places of destination. The red dots here show village location, and they show sort of the density of villages across. The larger the circle, the more villages there are in that area. This is what it looks like. Doesn't look particularly, this picture was taken in September, so late August, September, so in 2007. So we're seeing the results of the first monsoon, the first season monsoon. So it's relatively green. I'm up on the top picture is I'm up on a high landmark in the region, which was a Khmer outpost in the 14th century. It gives you a good sense of the landscape, very flat. The lower left picture is an up to what's often called a slightly higher elevation than those rice paddy fields. But you can see people are just waiting for rain to come in order to, in this particular field, their field is plowed, it's ready to go. They just are waiting for the rain to come. And in the right column, you can see, the right picture is, lower right is a paddy seedling beds for rice, and this man is going out to plant seedlings in the larger paddies that are ready that have gotten rain and are soaked. So when you go and talk to villagers about migration, they perceive environment as being really important for environmental conditions, and drought as being a real driver for their moves out of the place. And we were doing in 2007, we were showing them our data of patterns of migration in their village, and we were asking them, we've been coming back to your village now for 15 years, and you probably are wondering what it is that we have. So we showed them graphs and pictures of the patterns of migration, and we asked them to tell us a story about that pattern. And one piece of that story was always sort of this initial push out of the village as a result of drought and migration. And I'm not going to read this, you can read. There's another quote here. These translations were done by colleagues in Thailand. So I want to just make sure that when we think about our hypotheses, the warrant here prior to the hypothesis is that we're talking about rural agricultural resource-dependent livelihoods where migration is variable but growing adaptation to local ecological uncertainties. So our hypotheses are increasing uncertainty about environmental conditions, that is exposure to conditions different than the modal environmental conditions, and the prospects for sustained resource-dependent livelihoods will lead to higher outmigration. And the longer the exposure, the higher the likelihood of outmigration. These expectations are net of underlying cumulative process of migration. We have a starting sample in 1984 of individuals that are 13 to 30 years old, 4,000. By 2000, this sample is 6,141 people. We follow migrants to 4 destinations. This was a study design decision made back in 1993. And those are from a subset of the 22 villages. And we create a person-year file for this estimation, which is about 114,000 plus records. And we're looking at the risk of migrating out at any point in a year. And in that case, we have about 77,000 instances of out-migration. While I'm not going to show you results, one of our next steps is estimating return migration too in response to changing environmental conditions among those who have migrated out. Okay, so you can read that. This is what it looks like when you look at a pattern. This is spaghetti. What we have here on the bottom paragraph, bottom axis, the x-axis is year, and then percent of migration at any year and each line is a village. So you can see there's variation across villages in the percentage of migrants at any point in time, and that variability actually grows with time. But you also see an overall something of a curve, downward curve as we get to the later years. In another piece of work, we looked at the economic crisis 1997. That had a lagged effect on subsequent migration in the latter part of the wave. So what we've done is attach two kinds of environmental data to these records. One is the El Nino Southern Oscillation Trend, patterns of temperature, El Nino La Nina pattern, and we've also coded, attached to the files, the normalized difference of vegetation index values for the pixels in our site. So El Nino La Nina Southern Oscillation is we often talk about it, but it's a system of interactions between the Pacific Ocean and the atmosphere above it. And they're opposite events. El Nino and La Nina are opposite events in that system. So for El Nino, it's that generally temperatures are higher than average, and La Nina is when temperatures are cooler than average. What that means for those of us in the Pacific Northwest is that when you're having a La Nina year, it's time to buckle on your skis and go skiing, because there's a ton of snow in the mountains in the Pacific Northwest. When you're having a La Nina year in Thailand, that means that the monsoon actually extends for a longer period of time. You get a lot more rain, and it's a good thing. In an El Nino year, you tend to have more warm and dry conditions. So what we do with this is for every 3 months, they calculate an average temperature for that part of the world. And in this case, in Thailand, they look at the 3-month average per year, and we calculate, then they tell you whether or not that falls above or below the average. So the blue, in this case, the highlighted blue negative signals are La Nina average, 3-month averages, and the reds are El Nino temperature averages, and obviously the black is the neutral trend. What we do is we calculate, we use the, going back from May, we go back from May, which is the beginning of the plant rainy season for Thailand, and we count back the number of months of exposure, 12 months back and 24 months back of La Nina-like conditions or El Nino-like conditions. And what we do then is turn that into a, we turn those into, for simplicity's sake, we turn those into any set of 12 months that are 50% more of one of those conditions we treat as that condition. For the normalized difference of vegetation index, what this is, basically, I've got a lot of description here, but let me just say quickly that NDVI is a measure of greenness of vegetation. So as people have, and it's normalized around, because it's there's quite a lot of information that comes in on a near red and near infrared signal. They've developed techniques to help deal with some of the noise in the measure, and also get some typical, as you would know, standardized distributions variability in that signal. So these are the satellite that collects this data on a regular basis, and a picture sort of a green up relative comparison across place on green up and green down in mid-June. What we do is we take NDVI signals from the pixels that cover the Nong Rong district, and these signals, these NDVI measures, are collected every 2 weeks from each pixel, and we take that information, and in this case, here's this pixel for 1 year, 1984, for every month. And we can see the NDVI signal. This is, as you would expect, this green up period that you get in a paddy field, and the decline. So you've got paddies get really wet, so the signal goes down. There's not much green on a paddy. There's a lot of plowed, cleared space. You saw those on those earlier paddies. Paddies get planted, and you get a green up in the irrigation and a green down when it yellows and then gets harvested. So we have these patterns for every year and every pixel. And now that's a lot of information to deal with. What do we do with all that information? So what we do with those pieces of information, you can see in 1995, here's an example of 3 different pixels. And each of those pixels in the same year have different signals across time. So what we've done is we have to summarize all of that information to come up with something to say and to use as in the right-hand side of our equation. And what we've done is use a clustering technique developed by Adrian Raftery to look at the modal pattern versus the non-modal patterns to see how many different patterns we have of these green up, green downs that are distinct from each other. So that would be the last sentence, comparing the modal pattern with the unusual patterns of lesser and greater greening up and greening down. So as I said, we're using a model developed by Fraley and Raftery, and we use a statistic to distinguish between different clusters. We generated 9 different clusters based on using starting date, again, the Thai water year, May, April of the next year, and corresponding with the monsoon-based seasons and crops. And each village could then be associated with a pixel and its corresponding clusters for each year of the study. Let me show you an example of some of these clusters. The top one, number 1, is the modal category of green up and green down. And cluster 2, 6, and 9 are actually relatively wet signals of green up and green down. So the curves are steeper. So you've got a drop there's more water, and then a steep greening curve, and then a fall off. So what does this look like on our data? If we've got villages there on the column, far left column, you can see, and these are years across the top. The modal categories, those are the gray. This is the gray sections, and you see these off-year experience, off-modal categories of clusters. We use for our modeling approach, we use a shared frailty model, which is a type of hazard model for random effects. And in part, to deal with the clustered level of village level data and to control for some of the unobserved heterogeneity in the model, in the data. And we have a baseline set of controls, which I'll show you some results from, which include the sex of the individual, their educational status, marital status, migration experience, prior migrant experience, and our measure of migrant social capital, which is basically cumulative percentage of migrants in the village in the year prior. So we test the following models: baseline plus an El Nino, 50% or more, and El Nino meaning our three variables: exposure to El Nino, La Nina, and a neutral year, and then baseline of NDVI clusters. And all of those are T minus 1. Yeah, you look like you had a question, Marta. Okay. And our expectations are that we expect higher odds of outmigration with more months of exposure to El Nino events. And we have a, for NDVI, after a lagged year with a greener overall trend, we expect actually lower outmigration. And a cluster characterized by degreening, we expect higher outmigration. Let me just show you descriptively what we have here. The line is the trends in migration overall for the whole non-wrong area. And if you look at the lines, the bars, you can see these are patterns of number of months of El Nino, number of months of La Nina, and as I said, the percent migrant. You have to. This isn't actually the best visual because this is cumulative 12 months, 24 months prior. So you have to think backwards in time in terms of this bar represents accumulation of effects. And so it's measured at the end of the period rather than, so. So there looks like there's something like a lagged effect of El Nino events on migration. That is, migration bumps up a bit after, but it doesn't look. It's not terribly strong, and certainly La Nina events aren't necessarily changing the migration system particularly either in terms of holding people back. At least it doesn't appear that way. So. So that's just to give you a little. So here's our baseline measures of the odds of outmigration. It follows most of the other analyses that I've done in other places, in other outlets, publication outlets. So number of months prior migration makes a difference. Whether you've already been a migrant, you're going to migrate again. The number of months that you've been away in prior experiences will predict future migration. The older you are, whether you're a man, you're more likely to migrate, etc. When we add in El Nino, La Nina, and neutral events, here are our results. What we find is that La Nina events actually lower migration. That is, you get a lower outmigration as a result of a exposure to longer period of 50% more of La Nina events when you look at over a 12-month period. So we estimated two different models. One was looking back 12 months and one was looking back 24 months. So in the case of looking back over 12 months, you're less likely to move after having had experience in a La Nina, colder, wetter experience. But if you look back over 24 months and you've had 50% more of months over the last 24 months of El Nino-like conditions, your likelihood of migration actually goes up, which suggests that people are, that having been exposed to high levels of uncertainty for a consistently long period of time will actually propel you over and above the already existing conditions that, net of those already existing conditions that propel you out of the place. Now, when we look at these clusters, cluster 1 is our omitted cluster. In 3, actually, there are not enough observations in cluster 3 in our social data that it actually gets dropped out in cluster 3, 4, and 5. Actually, there are not enough observations in those clusters on the social side of things to it falls out of the model. So you can think of those as being actually ending up in the omitted category. But for cluster 6, 2, 6, and 9, which are our wetter years, we see a lower odds of out-migration than we do relative to the modal category of cluster 1, which is in the bottom left corner, by quite a bit. So I'm actually almost done here. So what we find in our study is that in this initial test of this, looking at variability, is that exposure, variability in exposure is a good possible measure using the El Nino La Nina event, but I'm actually not particular. I mean, it falls in our expectations, it works with our expectations, but one of my skeptical ideas here is that these are actually pretty close to year effects. So, and I'm not, there are other constituent things going on in Thailand that might be associated with, that might be coincidentally correlated with these year effects. I think the NDVI data is really a promising opportunity for a more refined measure. It's got a lot of temporal depth, a lot of information there that could be used. It does need some methodological validation to be used in other sites. So, for example, we know that in what those signals mean in this area. But you really need to actually calibrate your measures of NDVI with the particular land use land cover in those particular pixels. But I think it's actually NDVI could be a really valuable data source for other social science data that are out there that are longitudinal, and it would be relatively easy. So as I said, one of the things that we need to do next is to calibrate our environmental measure with land use and land cover. We also need to take into account other ways to observe migration. So several other studies that are out there currently and that have shown promising results is they've distinguished between distance, time, length of moves, permanency of moves, numbers of moves, and the possibility of return migration. So we need to complicate on our study the migration, what we're observing in terms of migration. We also need, as I suggested, to control better for some of the possible economic pushes, other things that might be going on that are coincidentally correlated with these particular years in our data, so that we're not over claiming claiming more than there is. And again, in our particular site, although we have qualitative data about perceptions of environmental risks, we don't actually have quantitative data on that component. So certainly that would matter. And finally, there's a key hypothesis out there that we haven't tested yet, which is that environmental stress probably intensifies existing migration processes, and we haven't actually checked those interactions. So that's all I have, and thank you. I look forward to your discussion and feedback.